Today we're going to talk about how to write the Tic Tac Toe O lathe code. So let's get right into it. Okay, let's take a quick look at the drawing. So we're making a O, or a ring, that is 950 thou in diameter, which means it should come nicely out of 1-inch stock, and 300 thou in thickness. It's got some chamfers and it's got a 600 thou hole. So we're going to go ahead and open our intro to CNC lathe code, and we're going to do a file save as, and I'm going to name it TTTO. I've already done this, so I'm going to go ahead and save over it. So we're going to go ahead and modify the code. So the first thing we're going to do is put down the drawing number for our part number, which is 24031, and our last name. Oh, this is the title of the project, and so this is a TTTO. And then who created it, and then today is the 24th, I believe I'm doing this on. And it is out of brass. It is 1-inch diameter stock. It is, all of these settings should be the same. The safe tool change, we are going to start with the facing turning tool, which is tool number 1 on our turret, so that would be fine. And then we're going to come down here to facing. And the big change is we're going to change this to 1.1 inches because it's 1-inch stock, and this will return to 1.05 inches. So now we have to turn the profile. So we've already faced. We've come across the face and cleaned it up all the way past center. And then the next thing we got to do is we got to turn this profile. So we're going to bring it back, and we need to know the diameter at the bottom of this chamfer. And the chamfer is a 25 thousandths, which if we take 25 here and 25 here, that is 95, or that's 90,000. The chamfer is 25 thousandths. If we double that, that becomes 50 thousandths. And then if we subtract 50 thousandths from 950, we end up with 900. So on our P command, on our first line to do the profile, this is going to be a 900 thousandth diameter, and then we are going to move into Z0. Doesn't need to be -0, but it's just Z0 to that point right there. Now we're going to do the chamfer, which is going to be a 2-line, an X and a Y. So we're going X to 9500, and the Z, I'm sorry, not an X and a Y, a Z. Z will be -0.25 thousandths, because that's how far we have to move in Z to get a 25 thousandths chamfer. The next move is not a curve, it's going to be a G01, and it will be a Z negative, so we have 30 thousandths is the whole thing. But we are also going to have to part this off, and on the machine we have a parting tool that has a thickness of 125 thousandths, or 1/8 of an inch, which we have to add to this. So if we take 125 and add 300, we get 425. We're going to add just a hair more so that we have a nice clean area for our parting tool to come in. We are then going to go to an X diameter of 1.01 or 1.1 inches, or 1.05, which is the same number as it is right here, and that is our roughing pass. Okay, now, so we've done a roughing pass, and it'll lay out the proper step downs, which won't be too many passes considering we are not taking off much material at all. And then our finish pass would be the same thing. Oh, we need to change these P's and Q's from P300 or Q300 to Q60 because we only end on line 60, and then this one would also have to be line 60. Okay, so the outside profile is turned minus the backside chamfer, which we will do in a minute. We're going to have to do a tool change, and we're going to do parting eventually, so we're going to add in another command. And in this command, I am going to just borrow the facing, and this will be a tool change. We're going to call this drilling. Okay, this will be a tool change, not to tool number 2 right now. We can actually copy this and paste it above parting, because we'll switch to tool number 2 to do the parting. But for drilling, we're going to do a tool change, and we're going to go to tool number 3. So that would be 303, which is the drill bit. And then we are going to go, so now we switch positions and we have a drill bit. We need to put the drill bit right on center. So we are going to go to G00X 0.0, which will bring it on center, and Z.1. So that means the drill bit will move and it'll align right with the center here. And then we just have to do a G01, and in this case, we are going to drill straight through. So we already determined that we need to get the drill bit 300 thousandths deep. Now, a trick with a drill bit on a standard 118-degree drill is if you take the diameter of the drill bit, which is 0.5, and you multiply it by 0.3, you need to add this amount to your drill to ensure that the entire point makes it through the hole. What we're accommodating for is the fact that we need to get this edge here all the way through the hole. So we need to accommodate for how much distance this triangle is. And the trick is to use the 0.3 multiplied by the diameter will give you how much that distance is. It's not exactly true, but it's always a little bit bigger. Short version is we want to go to 450 thousandths deep. So this will become a Z negative 0.45 deep. That way it will drill all the way through. So we've gone in that deep. We need to retract it. So we're just going to delete line 80. That'll be easy. And then we need to retract this back to G0.1, which will pull it out to here so that we can do another tool change. So we're going to copy this one and paste it again. This time we're actually not rotating the turret. All we are doing is moving. That's a mistake, so you might have to clean those up if I type those in wrong. So we did this tool change. We are going to change to tool number 13, which is the same turret location. We're just switching tools because we have what's called gang tooling, which means that our drill bit and our boring bar are on the same turret location. And so we've switched the tool, and we're going to basically copy the drilling cycle again with some small modifications. So we're going to have to go back at the end and change all the tool numbers. Okay, one thing to note, when I tried to run this, I tried to be lazy and not rewrite the line numbers, and you have to rewrite the line numbers because we're using these P and Qs, and if you're not careful, you'll end up with repetitive P and Qs. So what we need to do is when we jump down here, so this is 60, 310, 320, those will all work. This can be 360, 70, 90, and then these should be 400. And then I can come down here to the boring and do 500s. And so on. And this should, this is a problem you've got to make sure you do. Once again, we're going to bring it in. This time we are going to bring in the diameter at X 550. because remember we've drilled a 0.5 hole all the way through. So now we need to bore on the inside, and the inside diameter, the first pass is going to be at 550 and the second pass will be at 600. So we're just going to hand code 2 passes in. So we're going to go to 550Z, then our negative, this is only going to be negative 330 because that's how thick our part is. We're going to do a little bit more so we make sure we get past it. And then we are going to have to lower the diameter first, X, to like 0.525. So we've made it slightly smaller so it doesn't drag on the way out. And then N 200, G or Z 0.1, N 210, X 6.6, and then N 220, G01, because we were doing all of these in rapid, Z negative 3.305, and then another N230. So we done one pass in, retracted back a little bit, came here, came out, did another pass in. We're going to tract back a little bit. This is rapid though. X, we can go to X 0.55, and then N 240, and we can go to Z 0.1. So we went in at 500 or 550 thou. We retracted back in. We went into negative 305. Then we retracted to 525. Then we came out to positive 0.1. Went out to 600. Went in. Retracted to 555. Came out, and now we're ready to do our next tool change right here. And this time we are going to tool number 2. That is correct. And then we're going to do a parting. And in this case, we only have to do a parting with a backside chamfer. So it's slightly more complicated. So what we basically have to do is we have to come in, we have to cut a groove, retract, go over, cut an angle, and then finish the part. So first step is to bring it into the part. This is going to be 1.1, Z1. It'll come to right here. I'm working on the wrong side. We're going to go into where our groove is going to be, which is a Z negative 0.425. And then we are going to start a part. But instead of going all the way to the center, we are only going to go in slightly more than our chamfer. So we already determined up here the chamfer is 900, so we're going to go to 850 at 2.25 inches. And then we need to retract back to X 1.1. And now we're going to have to give some more lines of code. And 400, we are going to go to Z. We have to subtract 325 from 300, so that's 275. 0.275, that's a negative, because that'll bring the corner of the cutter to right above this point. And then we have to go X to 0.95, and then N 420, and then we're going to go X to 0.9, Z back to negative 0.425. So this will cut our angle. And then we can go N 430, and we can go X 0 negative, or we actually don't have to cut all the way through. So we've already drilled a hole. So we only need to part down to this 600 diameter. We're going to go a little bit more. So we're going to go to X 5.55. And then in case the part doesn't come off, we are going to do G0 X 1.1, and then we can do the Z5, which will pull it away. And then end of spindle, end of stop program. And there we go. We have our Tic Tac Toe O code written. When you power up this lathe, you're going to press and hold the power up button. It's going to take a few minutes to load. Now, what you're going to need to do is when it loads, you're going to get a screen that says what kind of simulator do you want. And you have to be kind of quick on the ball here. You can't walk off and come back because we need to switch it to the TL series lathe. So it's going to go through this whole cycle. And then it's going to be, I forget what number, it'll tell me here in a second as soon as it loads. I think it's number 4, and you have to press 4. So you got to read the list, because this will do all the different machines Haas makes. So here it is. Oh, it is a 0. So the default for us is the TL, so you can press 0 to advance it along. And there it went. And then don't forget to hit reset, alarms, reset, power up. Once it finishes loading. You're going to power it on, you got to press and hold. And then you're going to go ahead and bring up your code just like you did on any other simulator. And then you're going to go ahead and run it. And it's going to look kind of like a jumble of mess. You can use single block. And then you can press, every time you press the cycle start button, it will advance the code one line, and that will allow you to watch what it's doing each time. So there's our facing pass and so on. And there's our roughing passes, and you'll notice this isn't going down because it's doing that. Once you're done with this, show this to me, and of course we'll go run it on the lathe.